The alkali metals are the most reactive metals, and that's because they have only one electron to lose in order to react. Because they're so reactive, we don't find them in nature in their elemental state. They are always in the form of a compound. In order to isolate alkali metals, that is to separate them from the anions that they are naturally joined with, we subject them to electrolysis of the molten salt that contains them. For example, whenever we want to obtain sodium, we take NaCl, sodium chloride, and we heat it up so it is in the molten state. That's what this little L stands for in the equation. And we run an electric current through that system, and we end up with, at the anode, the chloride ion is oxidized such that its new oxidation number is 0. We'll get into more of these details later. At the cathode, which is on the lower right of this diagram, and there's also one here on the left side of the diagram, at the cathode, the sodium ion is reduced to sodium metal. In that way, we are able to isolate the sodium and get it into its elemental form. Alkali metals react with hydrogen to form metal hydrides. They react with water to form metal hydroxides, and, as you can also see here, hydrogen gas. Many of you may have seen a demonstration involving an alkali metal that is dropped into plain water, and this hydrogen that is produced is often ignited, and sometimes in a spectacular fashion. The alkali metals, of course, react with oxygen. Lithium tends to yield lithium oxide. The others yield, at least mostly, peroxides. And here we have a picture of potassium in water, forming flammable hydrogen and soluble potassium hydroxide. The alkaline earths are not as reactive as the alkalis. They have 2 electrons to lose instead of just the one that the alkalis have. Compared to the alkalis, they are harder, denser, and they have higher melting points. Calcium and the heavier alkaline earths react with water to form metal hydroxides and hydrogen, and here's an example equation of that. One of the alkaline earths, magnesium, has a protective coating around it of magnesium oxide that tends to prevent the magnesium from corroding very easily. That is a protective layer that doesn't slough off over time, as does the oxide coating on iron, for example. The protective coating is on top of the substrate, which is the underlying metal, and protects it. Hydrogen is, of course, a non-metal, but it doesn't really belong to any family. Certainly it's not an alkali metal, even though it's above the group that contains the other alkali metals. It reacts with other metals to form molecular or covalent compounds, and in its elemental form, hydrogen is best known for having been a culprit in the disaster of the Hindenburg, which you recall looked like that. Oops. Actually, that ship was called the Hindenburg, but that's not the one that we all remember. That one, after World War I, was scuttled, along with many other German ships. The Hindenburg that we all remember looks like that. It was filled with hydrogen, and it burned up in spectacular fashion in May of 1937, killing 36 people. The halogens. Astatine isn't considered to be a halogen, even though it's in group 17. Some people say that it is a halogen. Some people say it isn't. It doesn't really matter because we don't really know a whole lot about it. At standard temperature, fluorine and chlorine are gases. Bromine is a liquid. Iodine is a solid. There's a good reason for that, which we'll talk about later when we get into intermolecular forces. You notice that all of the halogens are Oberfinkels. They are diatomic elements. The exothermic reactivity of the halogens is dominated by their tendency to gain electrons. Certainly each of them wants to gain one electron to be like a noble gas. We add chlorine to water to disinfect it. When combined with hydrogen in aqueous solution, hydrofluoric acid is a weak acid, and the other three form strong acids. The noble gases are monatomic. They have completely filled s and p orbitals. Helium, neon, and argon have no known compounds. Of course, radon is radioactive. Krypton has only one known compound, and xenon has a few. You'll note that the only element that has enough oomph to react at all with any noble gas atom is fluorine, which is the most electronegative element. You might have had to have some radon mitigation done in your basement because radon is radioactive. Let's summarize the group trends. Some reaction patterns for the alkali metals include reacting with hydrogen to form a metal hydride, reacting with water to form a metal hydroxide and hydrogen gas, and reacting with oxygen to form peroxides. Unless the alkali metal is lithium, then the primary product is the oxide, lithium oxide, not lithium peroxide. A reaction pattern for the calcium and heavier alkaline earth metals is reacting with water to form a metal hydroxide and hydrogen gas.